Hello class, today we are going to be putting another piece into the puzzle of the physiology of female reproductive system. This is the hormonal control of the ovarian cycle, and this is specifically a large section of what I did my PhD thesis on, so I love this and I really feel like I'll be able to communicate it effectively. Professor tip, this seems complicated, but it's simple once you have an understanding of it, I promise. So, let's just jump into it. Regulation requires rhythmic function of hormones from the hypothalamus, the anterior pituitary gland, and the ovaries. These interact via negative feedback loop, meaning that they can shut themselves off, introduced in males. The HPG, hypothalamic pituitary gonadal axis, is an example of the feedback loop's core principle. Now, it's interesting that ovulation is triggered by a positive feedback loop mechanism. Positive feedback loops are incredibly rare. The only other one that we've learned in this class for this entire Anatomy Phys II is actually blood clotting. So everything else revolves around a negative feedback loop system, which means that the loop closes itself. Pregnancy, on the other hand, or ovulation, on the other hand, is triggered by a positive feedback mechanism, which I just think is fascinating. Now, the hormones of a 28-day menstrual cycle are as follows. I have the picture first, and then we'll talk a little bit about the hormones, but again, like always, pictures makes things easier to understand and look at. First tier of control. We start up at the hypothalamus. Now, similar in males, hypothalamus is going to secrete GnRH, or gonadotropin-releasing hormone. This is going to cause the second tier of control at the anterior pituitary gland to respond. It is going to release luteinizing hormone or follicle-stimulating hormone, depending on how the GnRH is released. Is it rhythmically, or is it in a large burst pattern? For this, you don't need to know. That's more endocrinology. Now, LH and FSH are going to go to the gonads. In females, gonads are the ovums. So we go into the ovary, and the ovaries are going to secrete androgens in response to luteinizing hormone. These ovaries are going to convert androgens to estrogen and secrete estrogens and inhibin in response to FSH. So let's look at this. Luteinizing hormone goes to the ovarian follicles. From there, it is going to release androgen. That androgen, ooh, we went way up there. Now, androgens are essentially male sex hormones for the most part, and they actually can get converted or aromatized into estrogens. So luteinizing hormone in the female produces androgens. Follicle-stimulating hormone goes to the ovarian follicles and causes them to secrete estrogens and inhibin. Now, the effects of this. The estrogens that are currently produced stimulate the dominant follicles to mature into vesicular follicles. These new vesicular follicles produce large amounts of estrogens, triggering an LH surge, or luteinizing hormone surge. And this luteinizing hormone surge and FSH are going to trigger ovulation. So, we have all of this estrogens and inhibin being produced. The vesicular follicle is going to create more estrogens. And if you see, these more estrogens are going to go up and create a positive feedback loop at the anterior pituitary gland. Because there's an increase in estrogens, that is going to increase the amount of luteinizing hormone going to be released, and because of that, this is going to continue until there is ovulation. Now, once ovulation occurs, you have this negative feedback loop kick in, where estrogens are going to inhibit GnRH secretion. Right now, this is confusing, but come back to this, look at this. This is the pattern. It's GnRH from the hypothalamus to anterior pituitary gland, which releases LH and FSH. These go to the gonads, remember, HPG axis. Here, the LH creates or causes the ovarian follicles to make androgens, which get aromatized into estrogens. FSH, follicle-stimulating hormone, tells the ovarian follicles to make estrogens and inhibit. This process continues and you get more estrogens, which causes the anterior pituitary gland to continue to release more gonadotropins, LH and FSH, and because of that, you eventually get a tipping point where there is an LH surge, where there's just going to be, boom, tons of LH into the system, and that is what is going to cause ovulation. Essentially, body produces enough of that to just, remember, eject the secondary oocyte with those granulosa cells around it, and the remainder of this vesicular follicle turns into the corpus luteum. That ovulation creates a negative feedback loop and stops this. Now, this is it written down. First tier control. The hypothalamus secretes GnRH, which is gonadotropin-releasing hormone. Here's how that hormone actually makes sense. GnRH. So gonadotropins are essentially hormones that are going to be released from the pituitary gland, specifically targeting the gonads. So gonadotropin, releasing hormone. That's what the GnRH does. It causes this to release the gonadotropins. GnRH, gonadotropin releasing hormone. I love it when scientists actually name it something that makes sense, because I won't confuse you with more information. Second tier control. The anterior pituitary gland releases LH and FSH in response to it. I have here depending on the signal, because if it's bursting or rhythm, don't worry about it. LH stimulates thecal cells to secrete androgens, primarily testosterone, and they target granulosa cells. So here at the ovarian follicles, specifically, it's targeting the thecal cells. That secretes androgens, which are essentially traditionally male sex hormones. Male sex hormones, not because they're only found in males, but because they are found higher in males. Same with estrogenicity or estrogenic compounds, which are more commonly found in females, but they're also found in males. These target the granulosa cells. Androgens will get aromatized into estrogens. Follicle-stimulating hormone stimulates granulosa cells in follicles to secrete estrogens, to convert the androgens to estrogens, and secrete inhibin. Estrogens typically stimulate solitary dominant follicles to continue developing into the vesicular follicle. So remember, as you see these, go back up and put it in context to here. Now we're understanding a little bit why things are happening. We're putting the pieces together. The new vesicular follicles produces enough estrogen to produce a positive feedback loop on the anterior pituitary to trigger a large increase of LH, called the luteinizing hormone surge. This is important. There's not a lot of positive feedback loops in the body because if you think about it, they can get out of control rapidly. This is an important one because that actually causes ovulation. So the LH surge is accompanied by increasing FSH levels, and these two things end up triggering ovulation. That leftover vesicular follicle becomes that corpus luteum, and the corpus luteum will produce additional progesterone, estrogens, and inhibin. Now, those increased estrogen levels and inhibin exert a negative feedback control on the hypothalamus and the pituitary gland. Estrogen inhibits GnRH and LH secretion, while inhibin inhibits FSH. This prevents other primary follicles from beginning to develop too early, because if you think about it, the body only wants to release a certain amount, because if it would just continuously release it, one, it would burn through your stockade of primary follicles way too quickly. Two, the body this cycle is designed to release a oocyte at a very particular time when the body has started to develop in the womb to have enough support for that zygote. If this cycle is interrupted or if it's disturbed or anything, it can dramatically affect the rate of success for puberty. For pregnancy, not puberty. Woof. Now, we are here. This corpus luteum, we have a schism of what's going to happen. Did pregnancy occur from this ovulation? If so, cool. Progesterone from the corpus luteum will inhibit the release of gonadotropins continuously for the duration ensuing the pregnancy. Pregnancy occurs, corpus luteum is like, I'm going to stick around. I'm needed. I'm going to keep sending some progesterone so that we're not going to tell the body to release another egg when we're already pregnant, because that would be waste. If pregnancy does not occur, or in the absence of fertilization, the corpus luteum will degenerate into the corpus albicans. Estrogen, progesterone, and inhibin levels start to decrease. GnRH levels start to increase, and the cycle begins once again. Here is a chart which essentially shows you the phases at the bottom, where you have the menstrual phase, proliferation phase, ovulation, and secretory phase. You can see the levels here of gonadotropin releasing, and you can see that they're going to increase until you have this huge LH surge during ovulation, and the levels are going to fall. At the ovarian hormone levels, you can see this also tracks exactly the same, where you have the menstrual phase where your estrogen levels are low, the proliferation phase where they're starting to increase and increase and increase, ovulation occurs, and then you have less estrogen and it's going to decline. However, at ovulation, you have a huge increase in progesterone. That is because of the corpus luteum secreting progesterone, essentially being like, hey, gonadotropins, we don't need any more, we don't want more LH, I don't want to produce another egg. This seems confusing, but we're stacking it on top of this cycle. They're going to work continuously. Now, the final puzzle piece, which actually intertwines and works very similarly, very beautifully, and will track and finally make all of this click together, hopefully. The menstrual cycle. So let's talk about the menstrual cycle. It's also known as the uterine cycle, and this is a series of cyclic events that the uterine endometrium goes through each month in response to the fluctuating levels of ovarian hormones. Remember, endometrium. Think back all the way to the anatomy of the female system. What is the endometrium? Well, I can tell you that it's comprised of two layers. You have your stratum functionalis, the functional layer. How nice is that, right? Functional layer, functionalis. This is the location of cyclic change in response to the fluctuating hormone levels. It will detach from the uterine wall and shed about 35 to 50 mLs of blood and other materials from the vaginal, usually monthly during menstruation, but not always. There is the thinner, deeper layer called the stratum basalis, or the basal layer. Again, nice naming. And this does not thicken in response to the hormone fluctuations, nor is it shed during menstruation. It replaces the stratum functionalis at the end of menstruation. Think about this as essentially the layer right at the end, towards the wall, and then the stratum functionalis is going to be built upon it. That comes down if you do not get pregnant, and then it builds out from the stratum basalis again. The uterine cycle goes through 3 phases and lasts on an average of 28 days. We're starting with the menstrual phase, which is days 1 through 5. This is the uterus shreds the stratum functionalis, resulting in menstruation. Look back up here. These are these 5 days right here. We have the proliferation or pre-ovulatory phase. These are days 6 through 13. The new stratum functionalis is starting to be generated with endometrial glands, spiral arteries, and veins. They begin to thicken or proliferate, and these glands enlarge, and the veins and arteries increase in numbers. Remember, pre-ovulatory. So after menstruation occurs, the body starts to, before the ovum is released, it's like, all right, let's start building this wall back up. Let's start getting these stuff ready, because maybe this one is going to get pregnant, or this one's going to get fertilized, and we got to be ready. So pre-ovulatory, you're prepping the stratum functionalis and building up those walls and those layers. Ovulation occurs around day 14. That secondary oocyte bursts from the mature follicle due to that LH surge, and the corpus luteum is formed. Secretory phase. The spiral arteries convert the stratum functionalis into secretory mucosal and endometrial glands. They secrete a nutritious glycogen-rich, essentially uterine milk, into the uterine cavity to sustain an embryo. So when we all think about females producing milk, we traditionally think about them coming from the mammary glands. However, during the secretory phase, there is a certain type of milk produced, which is essentially glycogen-rich, which encourages the embryo to implant and embed into the wall, because it's essentially like, hey, here's a lot of good and nutritious food. Come on, I know you want to be here. Now, if pregnancy doesn't occur, the stratum functionalis starts to die on day 28 and the menstrual phase begins. If pregnancy occurs, the secretory phase continues and the uterus continues to develop in preparation of the embryo for that whole process of development. Now, the photos below explain everything above and hopefully explains how the system works. Professor tip: use this photo to explain the menstrual cycle, the hormones, how long each phase lasts, and why. These are all of the ones before. You have seen this one, and this one. However, this one is new. These are the stratum functionalis and the regrowing of phase. So what I would do is I would start at the menstrual phase. Look all the way up, look at the levels of LH and FSH, what follicular phase we're currently in. We have sloughed off the stratum functionalis, the stratum basalis continues to be here. The proliferation phase, we're starting to rebuild that stratum functionalis in response to the estrogens that are coming from the LH and FSH, all the way back from up here, because of the ovarian follicles producing estrogens and inhibin because of this LH and FSH. That creates that positive feedback loop. And we are going to continue prepping that wall. We have LH and FSH, this huge surge, which causes the ovulation. Highest levels of estrogen are going to be around this time. And we start having those endometrial glands going to start getting ready to be in the secretory phase to secrete that uterine milk, which is essentially just glycogen-rich secretion to encourage the embryo to embed itself there. We have all of those spiral arteries and veins because the uterus has to be incredibly vascularized to provide enough nutrients and oxygen to that developing embryo. During this phase, the corpus luteum is formed, progesterone levels are incredibly high, which stops that positive feedback loop and tells the HPG axis, or essentially the HP part of the axis, to stop secreting high levels of these gonadotropins. The corpus luteum continues to secrete estrogen as well as progesterone. The progesterone is very important because it continues the development of the stratum functionalis. The body recognizes that that embryo, or that oocyte, is not pregnant. Pregnancy did not occur. Fertilization did not happen. And all of this work that it just did to build up the stratum functionalis, it's like, all right, we're starting again. Corpus luteum dies, corpus albicans is formed, progesterone levels crash, estrogen levels go low. This starts sloughing off. You bring it back to the menstrual phase. Now, we just went over a lot of hormones, both of the physiologies between the men and the women. And here's a table that separates the hormones via sex. It's divided by hormones, source, targets, response. You can see here for males, what does gonadotropin-releasing hormone do? Where's the source of it coming from? What's the target? And the response. That is going to be the same for men and women. Perfect. You remember one, you remember both. Same concept now for follicle-stimulating hormone. Both of them are going to come from the same place, whether it's man or woman. However, the target is going to be different because we have different gonads. I would go through this chart. I would do the trick about having a shape to block a target, to block the source, to block the hormone, to block the response. If you want to get really fancy with it, you can actually print this out, cut it out, and then try to line it up on a table. I know it's archaic, but it's a really good way to test yourself to see, okay, do I know what luteinizing hormone does in the female system? Do I know what luteinizing hormone does in the male system? Because all those can be questions. And then once you start figuring out, oh, this is the chart of the hormones, this is how they're regulated, here is the cycle of it, what does it do? The pieces are going to start to click together, and this, which seems so overwhelming and daunting right now, will start to make sense. I believe in you. On our next video, we are going to be talking about, now that we have the male and female systems outlined, how do we get those gametes to meet? See you then.